However, we see that A is parallel to B and M is parallel to N. So with this information, we know that all of our relationship rules hold true. So we know that all of these relationship rules are true. All right, so number 17, angle 4 and angle 7. So take a look back up at the picture, angle 4 and angle 7. Angle 4 and angle 7, what relationship do those have is the first question you want to ask. We know that these are corresponding angles. And corresponding angles, when our lines are parallel, are congruent. So angle 4 is congruent to angle 7. And this is because of the corresponding angles postulate. So corresponding angles postulate. Number 19. Angle 3 and angle 8, if you take a look at our picture, angle 3 is here and angle 8 is here. Those are alternate interior angles. And we know alternate interior angles to be congruent when our lines are parallel. So again, we have that they are congruent, and now it's because of the alternate interior angles theorem. Okay, moving on to the second page of the packet, still doing just the odds. We want to identify the angle relationship name first, and then from there we want to solve for x. So we have to set up an equation to solve for x. Okay, let's see if I can get a little bit closer. Okay, so we have here number 20. And number 20 says, I've got parallel lines, that's a great thing to identify first, and my angle relationship between these two angles, these are alternate exterior angles. So the relationship should be alternate exterior. And I'm actually doing 20 here. I should be doing 21. But let's go through 20 and then I'll do 21 as well. So one extra even problem for you guys. That's a bonus. Alright, so for alternate exterior angles, I know that these are congruent. So alternate exterior angles, when my lines are parallel, should be congruent. So the equation that I want to set up, so if I say, well, I'm going to have congruence, C-O-N-G for congruence, I need to set these two equations equal to each other. So 14x minus 1 equals 12x plus 17. And then from here, we just want to solve for x. So 14x minus 12x gets me 2x. 17 plus 1 is 18. Divide both sides by 2. I'm left with x equals 9. Okay, so 21 is where I should have started on the second page. My angle relationship, 4x minus 46 and 5x minus 44, these two angles are same side interior angles. So they're same side interior. And we know that same side interior angles, the same side, that S, these are supplementary. So for supplementary, I need to have something plus something else equals 180. That's how my equation should be set up as. So I'll take one of these angles, my 4x minus 46, plus the other angle, plus my 5x minus 44. This should equal 180. So I can easily solve for x now here. 4x plus 5x is 9x. Negative 46 minus 44 is negative 90. So minus 90 equals 180. And then add 90 to both sides. I have 9x equals 270. Divide both sides by 9. I'm left with x equals 30. So I have x equals 30. Okay. Number 23. So for number 23, my angle relationship that I have here, so I should see for 23, I have, again, alternate alternate interior angles. They're on all opposite sides of the transversal, and they're on the inside of my coplanar lines. So I have alternate interior angles. And for alternate interior angles, I want congruence. I know that when my lines are parallel, I have congruence. So to solve for x, I have one piece equals another piece, the other angle. So I have my first angle, my 10x minus 7 equals 8x plus 5. I can easily solve for x now. First, I'll subtract 8x from both sides, and I'll be left with 2x. And then I'll want to add 7 to both sides, and that leaves me with 12. Dividing both sides by 2, I'm left with x equals 6. Okay. Number 25. Number 25 is a little bit different. It says, in a complete sentence, explain what is wrong with the given diagram. So first, let's see here what we have. What's the angle relationship that we're dealing with? We have 56 and 114. These are same side exterior angles. So we know that with parallel lines, our same side exterior angles should be supplementary. So I'll say should be supplementary. Well, let's double check. 56 plus 114 should be 180 if what we're dealing with is true, but this is actually 170. So either our lines aren't actually parallel or our angles are incorrect. So for my complete sentence, I would say my same side exterior angles should be supplementary, but they are not. And that is my complete sentence. They should be supplementary, but they're not. So either what we have in for our angles is wrong, or our lines are not actually parallel. Okay, let's move on now to the next page. So this was second page. Let's go on to the third page. So we're starting now at number 27. Number 27, so 26 through 29 is asking to find the value of x that makes these lines parallel. And so we're trying to prove parallel. So right off the bat, we know that we're dealing with converse postulates or theorems, converses, because we're trying to prove parallel. So, number 27, what is my angle relationship here? These are same side interior angles. So for same side interior angles, I'll list this up in the corner kind of small, just a note to myself. For same side interior angles, I want supplementary. So I want to set up an equation and solve for x such that I would get these angles adding up to 180. So let's do just that. Let's add them up. 4x plus 10 plus 7x minus 6 equals 180. We can find the value of x that would make this true. 4x plus 7x is 11x. 10 minus 6 is positive 4. That equals 180. 11x equals, if I subtract 4 from both sides, this equals 176. Divide both sides by 11, I'm left with x equals 16. So if I were to plug my x back into these angles, I would find that this angle plus this angle is in fact 180 degrees. Therefore, these two angles are supplementary. So I have supplementary same side interior angles, and so by the converse of same side interior angles theorem. So using the converse of the same side interior angles theorem, I know that these two lines J and K are in fact parallel. Alright, so we want to set up a similar problem for 29. 29 says that I have two angles here. Well, one's kind of in the interior and one's on the exterior. So Am I using just one theorem or postulate to find this one? I'm not, because I don't have a relationship between these two angles. But what do I know about them? Do I know that they add up to 180? Well, I could say that 2x plus 55 plus 3x plus 65 equals 180, because if these lines were parallel, and that's what I'm trying to prove, this angle right here, the 3x plus 65, would have the same value. It would be congruent to this angle down here, its corresponding angle. And then this angle would form a linear pair with this angle. So we've kind of done a second step. But there is not one single theorem or postulate that we can use to prove this. There are two. So we would be using the linear pair postulate and the corresponding angles postulate. But we would be using the converse of the corresponding angles postulate. So here, let's see what we find. 2x plus 3x is 5x. 55 plus 65 is 120. That equals 180. Subtract 120 from both sides. I'm left with 5x equals 60. Divide both sides by 5. I have x equals 12. All right. Number 31. So let's move on to number 31. Are lines P and Q parallel? So 30 through 35 are asking if these lines are parallel, and we have to identify if they're parallel by looking at the angle measures that were given, and then indicate why or why not by giving the appropriate postulate or theorem. So 31, 68 degrees and 70 degrees. Well, these are corresponding angles, right? And if our lines were parallel, our corresponding angles would be congruent. 70 and 68 are two different measures. So I would say, no, not congruent, because corresponding angles should be congruent. And in our example here, they're not. 68 and 70 are not congruent. All right, 33. Do I know that my lines are parallel with the information that I'm given? Well, I know that this is a linear pair, and linear pairs are supposed to add up to 180. 110 plus 70 is, in fact, 180. But does that give me any information on any angle on line P? And since I have no information from any of these angles, I can't make any assumptions about these two lines being parallel. So for this one, I would say there simply is not enough information to conclude that lines P and Q are parallel. I'd say not enough info. And then for 35, I have vertical angles. And we know that vertical angles are supposed to be congruent. And yes, x and x are the same degree angle, so yes, these are congruent. But again, similar to 33, am I receiving any information on line P? I'm not. So again, for this one, there's not enough information to help me identify if these lines are parallel. Not enough info. Okay, let's move on to the next page. And I want to use this image to determine which lines, if any, are parallel. And then I want to justify my answer. So when you see something that says justify, for this unit specifically, it's going to mean which postulate or theorem or which converse postulate or theorem are you using. So taking a look at number 37, I have angle 1 and angle 6. Angle 1 and angle 6, again, these are vertical angles. Does that tell me any information on line B or line L? It does not. So here I have not enough info to talk about any lines being parallel. Not enough info. Not enough lines. Sorry, not enough info to let me know if any lines are parallel. Alright, angle 5 is congruent to angle 10. So if angle 5 is congruent to angle 10, these are alternate interior angles, and alternate interior angles are in fact supposed to be congruent for parallel lines. So which two lines, however, now are parallel? We've got 4 that we're dealing with. We need to identify the correct pairs of lines that are parallel. Well, A is my relevant transversal because line A touches both angles 5 and 10. My two coplanar lines would be M and L. So line M is parallel to line L. And this is by, remember, whenever we're proving parallel, we are using a converse theorem. So M and L are parallel by the converse of, and these are alternate interior angles theorem. Converse of alternate interior angles theorem. Okay, let's go through 8b. These are our proofs. I would like to prove the alternate interior angles theorem. And we're going to use this diagram here. My first statement is that L and M are parallel lines. My first reason for that always is that this is what is given to me. Next, I say that 2 is congruent to 6. How do I know that angle 2 is congruent to angle 6? I'm going to add my markings in here to identify. These are corresponding angles, and my lines are parallel. So, with the parallel, I know my rule holds, so I know congruence. So, by the corresponding angles postulate, I know my lines are parallel, or I know that my angles are congruent. Next, I state that angle 4 is congruent to angle 2. I say that 4 is congruent to 2. What's the relationship between 2 and 4, these two angles? These are vertical angles. So, by the vertical angles theorem, or VAT for short, I know that angle 4 is congruent to angle 2. Next, I'm stating that angle 4 is congruent to angle 6. And I know this because both of those angles are congruent to the same angle. 6 is congruent to angle 2, and 4 is also congruent to angle 2. Therefore, by the transitive property of congruence, angle 4 is congruent to angle 6. Your reason for this should not be, well, aren't those alternate interior angles, so can't we use the alternate interior angles theorem? We cannot, because that is exactly what we're trying to prove. We can't use the theorem that we're trying to prove in our reasons below. So transitive property of congruence is the reason for why we can say that angle 4 is congruent to angle 6. This then proves that the alternate interior angles are congruent. That is the alternate interior angles theorem. Okay, 43. 43 is proving the converse of the same side interior angles theorem. We're proving the converse. So, I would like to have that it's given that the measure of angle 3 plus the measure of angle degrees. So this is my first statement. My first reason is that this is given. And then my next statement is that the measure of angle 6 plus the measure of angle 7 equals 180. Well, the relationship between 6 and 7 is that they're a linear pair. So by the linear pair postulate, I can say that the measures of these two angles add up to 180. Next, I say that the measure of angle 3 plus the measure of angle 6 equals the measure of angle 6 plus the measure of angle 7. I know this because both of those pieces are equal to 180. So again, if two things are equal to the same thing, then they're equal to each other. This is the transitive property of equality. And be careful, it's a property of congruence when we deal with congruent symbols, and it's a property of equality when we deal with equal signs. Alright, so my next statement, I'm missing something now. It looks like I've gotten rid of the measures of angle 6 on both sides. I have subtracted them, so I've subtracted the measure of angle 6 from both sides, and this is using the subtraction property of equality. And I'm left with the measure of angle 7 equals the measure of angle 3. The next step is filled in, statement and reason. I go and say that the angle 3 is congruent to angle 7. This is the definition of congruence at work. Going from the measures of the angles being equal to the angles themselves being congruent. And then my last statement says, now I have 3 and 7. I know that angle 3 is congruent to angle 7. I have congruent corresponding angles, So whenever you see proving parallel, the first word you should know is converse. We're going to have converse of something. Well, 3 and 7 are corresponding angles, so the converse of corresponding angles postulate. Okay, let's move on to the next page. The next page is topic 9. Number 45. I want to find the slope of each segment in the graph, and we have 4 different segments. I'd like to find the slope. So for 45, I'm looking at the slope of segment CD. Well, let's do our rise over run. We're going down 2, so minus 2, and we're going to the right 3. So the slope of CD, I'm going down 2, so I have negative 2 over my run, which is 3, negative 2/3. And then I have 47. The slope of segment GH, here we start on the left. I'm going down 3, so minus 3, and over 2, so minus 3/2. Okay. Topic 9b, determine if each pair of lines is parallel, perpendicular, intersecting, or coinciding. Okay, so 51, sorry, let's do 49. 49, I have 2 over 7, so 2/7 x plus 2, and y equals 7 over 2x minus 6. First off, are they parallel? Oh, sorry, 49. For these lines to be parallel, I would need the slopes to be the same. Are my slopes the same? No. So automatically I know that they're not parallel. To be perpendicular, I would need them to be negative reciprocals. 2 over 7 and 7 over 2, yes, those are reciprocals, but is one the negative reciprocal of the other? It's not. So